Okay, so this is the video for 6.2. So you come to 6.2, and if you're watching the video, you've probably already done that. And you click that, and you have to wait for your worksheet to download. So then you hit that, and it'll open up in a Word document. Okay, so this first problem says the vertical position, not horizontal, of an object modeled by a parabolic path is given by this formula. So what we have is we have a parabola that looks like this, right? And we could find out the vertical position, meaning how tall, how high this is for any given time. Okay, so this is the time down here on this axis, and this is the height up here. Okay, so this formula will give us anywhere along this path the height of this projectile based on the time that we have. So that's what this is. G is, so S is the vertical position. S little zero, they call that naught, N-A-U-G-H-T, so S naught. That's the initial position, which most of the time is going to be zero, but sometimes it's going to be above ground a little bit, okay? V naught means the initial velocity. So like, for example, if I'm kicking a football, the football leaves a little bit higher than ground level because it comes right off the foot, but it's in contact with the foot for just a minute, and then the foot doesn't go with it. So right when it leaves the foot, it has some speed, it has a velocity. So that's this initial velocity, okay? Uh, Same like out of a gun, when you fire a shell, inside of here, it's got all the powder and the flame, the compression, everything pushing that bullet out. But as soon as it's out here, it leaves that air and stuff starts going away. And so the point that it leaves the barrel is the velocity, and then your shell goes something kind of like this. Okay, your lead casing, your bullet, whatever you want to call it. So anyways, it follows kind of a parabolic motion path as well. So anyways, this formula is for anything that has a projectile, like a trajectory like this. So a basketball shot, a football punt, if you throw the ball, if you throw a rock, if you jump off the diving board, you're going to go like this. Okay, um, depending on how high up and that, you might be more like this. But anyways, all of these things can be modeled by this formula. So, and everything goes to the ground because of gravity. And depending on whether we use feet per seconds or meters per seconds, it depends on the formula, or depends on what's in the problem. But you need to have everything the same. So if it's in meters, it needs to be meters. If it's in feet, it needs to be feet. So that'll be a crucial thing to understand as we go throughout this. It says a clay pigeon launcher built into the ground launches a clay pigeon from ground level. So this means that the original position that it leaves from is zero. So little s sub naught is zero. Initial velocity, so v naught equals 33. So if I plug stuff in here, that'd be a 33. This would be zero. How long does it take for the pigeon to come back down to the ground? So we're assuming that it's on flat ground. It's going to fly up and it's going to come out here and it's going to land somewhere out here. We want to know how long does it take. Well, the ending position out here is also zero because it started at zero, it comes back down to the ground, so it's zero. So our ending position is also zero. So now I can just plug this stuff in and solve for time. Okay, so I'm going to plug that in and solve for time. I'm going to get rid of my parabolas over here and plug stuff into my formula. So S is 0, negative 1/2, and we're doing meters per seconds with the velocity, so I'm going to use the 9. Gravity is 9.81 meters per second squared, plus my initial velocity, which is 33. Oh, whoops, I forgot the time on this one. That's the important part. Time squared. 33 times t, plus my initial position, which is 0. So now what I have is 0 equals negative 1/2 times 9.81. So negative 1/2 times 9.81. Enter. And we get that it's 4.905. So this becomes negative 4.905 and we have t squared still plus 33t. That's a 33. I don't know what happened, it became a 2. 33t plus 0. So I now have an equation I can solve. And remember, if I just have a t in each of these, I can factor a t out. So now what I have is t, and I'm going to put the 0 over on this side. It doesn't matter if it's on the left or not. Negative 4.905 t plus 33 equals 0. So now I put each of these, once you get it factored, you can put each of those equal to 0. So t equals 0, which we know that at time equals 0, it's at ground level. So yeah, we know that's going to be an answer. But here's the other one that we really want. Negative 4.905 t plus 33 equals 0. So I minus the 33 from each side. So negative 4.905 t equals negative 33. So I'm going to take negative 33 and divide it by negative 4.905. So negative 33 divided by negative 4.905. And that's 6.73. So t equals 6.73 seconds. So on my parabola, at time equals 0 and 6.73, that's how long it takes for this thing to travel in through the air. So it's up there quite a while. When does it reach its maximum height? Well, its maximum height is going to be halfway because that's the top of the parabola. So I can just take this answer and divide it by 2, and that'll give me the time for its maximum height. So 3.36. So maximum height is 3.36 seconds. So that's how much time. Now what is the maximum height? Well, I plug that back in to this equation. Okay. And I plug in 3.36 because now I know how long that thing's in the air for its maximum height. And its initial velocity is 33. The time is 3.36 plus 0. So now I just type this into the calculator and that'll give me my maximum height. So negative 1 divided by 2 times negative 9.81 times 3.36 squared plus 33 times, oh, one too many threes, times 3.6. Enter. So 174 approximately feet. Okay, so what is its maximum height? 174 feet. Because we've kept 2 significant digits everywhere else, we probably should keep 2 as on this as well. So 17.18. So when you go to write this down on your answers, put 174.18 feet. Okay, so those are the answers you're going to put down in the questions. Okay. So when I talked about significant digits, it would be 174, just three significant figures. So 174, that would be my significant figures. So you're just going to type 174 feet in, okay? And so now we can move on to the next question. It's often really helpful to draw a triangle so you understand what's going on. It says the height of a triangle, so we have a triangle. We have the height, okay? So we're talking about the height of the triangle is 2 feet less than the base x. So this is x, that means this is x minus 2, because it's 2 feet less than the base. The area equals 40 feet. Area is always in feet squared. So now that we have this, we need to think, how can I relate these and my given information to create an equation? And if you remember, the area of a triangle is 1/2 base times height. Well, I know the area is 40, so I put 40 in there. 1/2 my base is x, my height is x minus 2. So I now have a problem where I have just x's. I could figure out how to solve this. First thing I'm going to do is get rid of this half. So you could divide by a half if you'd like. Remember, dividing by a fraction is the same as multiplying by its reciprocal, so it's the same as multiplying by 2. So those cancel off. 2 times 4 is 8, so that's 80 equals x times x minus 2. If I distribute that x, I now have x squared minus 2x equals 80. And I'm going to write it over here because that looks really sloppy. X squared minus 2x equals 80. Whenever we have a problem like this, we want to get it equal to 0. So I have x squared minus 2x. So I minus the 80 from each side. So I minus the 80 equals 0. The reason we want to get it equal to 0 is because remember, if we have this, if I have something times something equals 0, one of these two has to be 0 to equal 0. And so then I can just say, well, it's either this one equals 0 or this one equals 0. So now we're going to ask ourselves what multiplies to be 80. Well, 80 is 1 and 80, 2 and 40, 3 doesn't, 4 and 10, 5 and 16, 6 doesn't, 7 doesn't, 8 and 10, and that's all of them. But which of these subtract to make 2? Oh, 10 and 8. So there it is, x minus 10 and x plus 8, because this is a negative in the middle, so my bigger number is negative. It's the same thing as if we'd have used the box, x squared negative 80, that makes negative 80x squared. And we put in a negative 10x and a positive 8x. So x and x minus 10 and 8. Okay. So now that I have that factored, I can put each factor equal to 0. Okay. So that makes x equals 10 and x equals negative 8. Well, it doesn't make sense to have a negative length of a triangle, so that one doesn't work. So the only one that works is x equals 10. But it doesn't ask you, it doesn't say what does x equal. It says what are the base and height measurements. Well, the base is x, so that is just 10. And the height is x minus 2. So 10 minus 2 is 8. And now we have met the requirements for that problem. All right, so now moving on to question number 3. It says a rectangular garden. So again, draw a picture. It'll really help you out. So a rectangular garden, that's close to rectangular. It says the covers 60 yards squared. So what that means is that the area is 60 yards squared. It says the length and the width. The length is 3 feet longer than the width. Well, if I call this x, then this one is x plus 3. It's 3 feet longer. Now it says find the length and the width. Well, I know the area of a rectangle is length times width. So it's x plus 3, that's the length. The width is x, and the area is 60. So I have x squared plus 3x, because I distribute this x to both of them, equals 60. And so now I'm going to make it equal to 0. So remember, anytime you have a squared and an x, you want to get it equal to 0, okay? So I minus the 60 from each side. So minus the 60, and I get equals 0. So now we're going to try to factor this again. And I'm going to, multiples of 60 are 1 and 60. 2 times 3 makes 60. 3 times 2 makes 6, so that's 60. 4 and 15, 5 and 12, 6 and 10, 7 doesn't, and 8 doesn't, and 9 doesn't. So those are my choices. Do any of these multiply to be negative? So one of them needs to be negative and then combine to be uh, 3. So I look at this and not seeing anything. So I'm not seeing anything. So what I've got to do then is use the quadratic formula. So I know that A equals 1, B equals 3, and C equals negative 60. And I know the quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. So now I just plug stuff in. So negative 3 plus or minus 3 squared minus 4ac all over 2a. And so now I'm just going to type that in my calculator. The 3 squared. So actually I can do this. I can just do it all at once. I'm going to go parentheses negative 3 plus the square root of 3 squared minus 4 times a times c. Then I'm going to come out, close my parentheses. So that's the top divided by 2 times 1. Enter. And it's 6.39. And then if I hit second enter, now I can come back and do the minus version of it. So I just have to change that plus to a minus. And that gives me a negative length. So that doesn't make sense to have a negative length. So the only one that works is 6.39. So come back to this. So 6.39 is what x equals. So that's the width. And length is 3 more than that. So I add 3 onto 6, and that makes 9. So 9.39. And we're just going to round this to the tenths. So 6.4 and 9.4. And that's the answer for question number 3. So question number 4 is a little bit long, but we'll work our way through it. It says the college football punter will average kicks of 50 yards. So that's this distance is 50 yards. Okay. And a hang time, so the time that it takes to go that is 4.8 seconds. So the football actually travels in a path like this. Okay, we're assuming again that it's on a nice calm day, there's no wind, there's no air resistance, it's just, okay. Given this information, how high will the football be at its maximum height? Well, remember this formula from at the very beginning, this S equals negative 1/2 gt squared plus v naught t plus s naught. Remember, that's our position. So it says, given this information, how high will the football be at its maximum height? Well, we don't know. And if I try to plug stuff in, so it says the initial position, so s naught equals 1.5. The time is 4.8. We know what the gravity is, but we don't know the height, if I put that in, or the initial velocity. So what I can do though is I know the height at the end. When it comes back down over here, the height is at 0. So I know that I could plug 0 in for that. And then this yards doesn't really matter, 50 yards. 4.8 seconds given the how long. Okay, so this is in meters, which is good because yards isn't one of the ones we have our information for, but we know that it's 9.8 meters per second squared for gravity. So acceleration due to gravity is 9.8 meters per second squared. And our time to travel the whole thing is 4.8 seconds. So what we're going to solve for is the initial velocity plus v naught. Some people use a little vi for initial velocity, and either way is fine. And then the t is 4.8 seconds, so that's how long it took. And the initial position was 1.5. So what I'm going to do is I'm going to type that right into my calculator, this part on the left, okay? So I'm going to type in negative 0.5, that's the 1/2, times 9.81 times the time, which is 4.8 squared, and then I'm going to add it to this 1.5. So that gives me negative 111.51. So negative 111.51. So I have negative 111.51 equals 0 plus my initial velocity times 4.8. So I'm just going to add that to the other side. So I now have 111.51 equals v naught times 4.8. So to find my initial velocity, I just have to divide by 4.8 now. So my initial velocity, so I go back to my calculator, and it already has the 111, so I just divide that by 4.8 and realize that that negative is gone. So it's 23.2 seconds. Okay, so the initial velocity, not seconds, 23.2 meters per second. So that's the initial velocity. So we've done the first part. We found the initial velocity. So how high will the football be at its maximum height? Well, now I can use the maximum height occurs at 2.4 seconds. So the maximum height, I can now plug it into that same formula. S equals negative 1/2, negative 9.81, 2.4 seconds squared. Okay, so that's seconds squared. This is meters per second squared. So I'm plugging stuff in, and we're plugging in 2.4 because remember 4.8 is the whole time, so halfway there is going to be the highest height. So I took 4.8 and split it in half. Plus the initial velocity, which we now know is 23.2. The time is 2.4 plus 1.5. So now I can just plug this whole thing into the calculator. So I'm going to go back to my calculator, and I'm going to type in this stuff right here. So negative 0.5 times negative, whoops, not negative 9.81, times 9.81. That negative shouldn't be there. Times 9.81 times 2.4 squared plus 23.2 times 2.4 plus 1.5. So the maximum height is 28.93 meters. Because remember, we're not in feet, we're in meters. So 28.9 meters. So 28.9 meters. Okay, so that's going to be the maximum height on that, based on this formula stuff, okay? So that's our maximum height. So that's all that we're supposed to do for that question. We're supposed to find the initial velocity, the max. So we're supposed to be maximum height and initial velocity. Okay, so it says the gas mileage M for a certain vehicle can be approximated by the formula m equals negative 0.04x squared plus 3.6x minus 49, where x equals the speed of the vehicle in miles per hour. At what speeds will this car get 30 miles per gallon? So this is the m, the gas mileage, okay? So it's saying if I plug 30 in for m, how fast, because that's what x represents, is the speed, how fast does this car need to be going to get 30 miles to the gallon? So remember, we want it to equal 0. So now that I've plugged stuff in, I now need to minus 30 from each side. Okay. So now I have negative 0.04x squared plus 3.6x minus 79 equals 0. So now I can just plug it into the quadratic formula, that negative b plus or minus b squared minus 4ac all over 2a. So I know that a equals negative 0.04, b equals 3.6, and c equals negative 79. So negative b, negative 3.6 plus or minus the square root of 3.6 squared minus 4a, which is negative 0.04, c, which is negative 79, all over 2a. And so again, I just go right to my calculator and I plug that in all in one step. Okay, so there it is over here. So I'm going to go parentheses negative 3.6 plus the square root of 3.6 squared minus 4 times negative 0.04 times negative 79. Go outside of my parentheses, or my square root, close my parentheses, divided by parentheses 2 times negative 0.04. Hit enter. And it says 37.9. And now I'm going to hit second enter. And I'm going to go back to the beginning and change that plus to a minus and hit enter again. So at 37.9 and 52.1. So 37.9 and 52.1. So if this person is going that many miles per hour, they're going to get 30 miles per gallon. Okay, so of course this is the better option because you're going to go further for your amount of gas. So they both get 30 miles per gallon, but this one you're going to cover a lot more country. So of course that'd be the better option, but you're supposed to put both of them. So you'll put both of those for your answer. So there'll be two answers on that. Okay, in a round robin marbles tournament, each player plays every other player exactly one time. The number of matches n is given by the equation, so that's n, equals 1/2 n times n minus 1, where n is the number of little n is the number of players in the tournament. If 45 matches, so that's the big N, how many players were in the tournament? 1/2 n minus 1. So again, I'm going to get rid of that 1/2, so I'm going to divide by 1/2. And remember, dividing by a fraction is the same as multiplying by its reciprocal. So 90 equals n times n minus 1. So I get n squared minus n equals 90. So now I minus the 90 from each side. So I now have n squared minus n minus 90 equals 0. Okay, so again, we're going to factor this. And again, we're going to say what multiplies to be 90? 1 and 90, 2 and 45. Again, if I had the little rectangle, I'd be doing the same thing. I'd have x squared and negative 90. I would have multiplied those, and I would be at this point right now. And then 3 times 3 makes 9. 4, I don't believe, goes into it. 5 and 18. 6 I don't think 6 does, but maybe it does. Looks like it does. 6 and 15. 7 doesn't. 8 doesn't. 9 and 10. But I need to find the one that when I subtract them, I get 1. So 9 and 10. And if the 10's negative, I get a negative 1. So that's negative 10 and 1. And I'd have x minus 10 and x plus 9. So I have n minus 10 and n plus 9 equals 0. Now that I've got it factored, I can put each of those factors equal to 0. So now I just add the 10. So I get n equals 10 minus the 9. So n equals negative 9. So here's what I did. I added the 10 to each side. I minus the 9 minus the 9. So n equals 10 and n equals negative 9. Well, it doesn't make sense to have negative number of players. So the only one that works is 10 on that one. Okay, so the police department uses a formula to determine the speed at which a car was going before the brakes were applied. Depending on the weather, they use different coefficient values for friction. They measure the skid marks and enter the information into the formula d equals 0.0016 r squared plus r. The d is the distance in feet the car traveled after the brakes were applied, which is the length of the skid mark, and r is the speed of the car in miles per hour. If the distance a car traveled while applying the brakes is 52 feet, so that's the d. So I replaced the d with 52. What was the speed? So we're trying to calculate r. And so now I have this. Since I have a squared r and just a plain old r, I want to get it equal to 0. So I'm going to minus the 52 over. So I now have 0 equals 0.0016 r squared plus r minus 52. So I now have the information I need for a quadratic formula. So a equals 0.0016, b equals 1, and c equals negative 52. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 1 plus or minus 1 squared minus 4a, which is 0.0016. C is a negative 52 all over 2 times 0.0016. So again, now I just go to my calculator. I'm going to plug that right in. Clear this off. So I go negative 1 plus second square root 1 squared, which is still 1, minus 4 times 0.0016. Whoops, one too many zeros in there. So I delete one out. Times negative 52. I go outside of this. Whoops, I should have parentheses. So I'm going to insert a parenthesis right here. Divided by parenthesis 2 times 0.0016. And hit enter. And it says 48.27. So now I'm going to try the other one. So I hit second enter. I move it back to the beginning, and I change that plus to a minus. So I change that plus to a minus and hit enter. And it's a negative 673, which doesn't make sense to have a negative number going on. So the only one that works is 48.3 miles per hour. We'll just put it at 48 miles per hour. Okay. So this one is 48 miles per hour. We'll round to the nearest whole number. Okay, so a rock is launched from a catapult and travels with an initial velocity of 30 meters per second. The height of the projectile at any time given t can be found using this formula. What will you set h equal to in the equation to find how many seconds it takes for a rock of this size to hit the ground? Well, if the rock's going to hit the ground again, it either hits the ground at the position of 0 or 0. Okay? It's still 0. If that rock goes like this, the ground is still 0. So the height of this is still 0. So h, the height of this. So the height is 0. How long will it take before it hits the ground? So we're just going to plug that in. and say 0 equals negative 15t squared plus 91.8t. So now I just need to solve. So I'm going to take a t out. So I'll have negative 15t plus 91.8. So that's factoring. And I'm just going to put the 0 over here. So if I set each of my factors equal to 0, I get t equals 0, which of course we already knew. When time is 0, yeah, the height is 0. It hasn't taken off. It hasn't gone anywhere. But now I need to solve this other one. That's the piece that we really are worried about. So negative 15t plus 91.8 equals 0. So now I minus the 91.8 from each side. So negative 15t equals negative 91.8. So now I just divide that by negative 15. So I go to my trusty calculator. Come on, calculator. We're going to go negative 91.8 divided by negative 15. And it tells me that it's 6.12 seconds. So time equals 6.12 seconds. So whatever rock this is, it takes 6 seconds. So, you know, that's up in the air for a while. They can watch it in slow motion, be like, here it comes, hide. Anyways, yeah. Sorry, there's nobody here. I have to talk to myself. All right, number 9, it says identify all the factors. That just means we're supposed to factor this. So if I go through the numbers that multiply to be 120, I have shown you this on the calculator, but just to refresh your brains, if I go to y equals, and I go 120 divided by x, and I hit second table, these are going to be the numbers that multiply to be 120. So I could just write those down if I wanted to. I might as well. Why not, huh? So 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 7 makes a decimal, 8 and 15. Scroll down. 9 is a decimal, 10, and then 12. So that's all of them because it goes 10, 11, and then 12. So, you know, when these numbers start counting back going up this way, you know you've written them all down. So now I can just go back and look at my problem. So it has to multiply by negative 120 and add to be negative 26. So that means my bigger one is negative. So these are all negative. So if I combine these, that makes negative 2, that makes negative 7, that makes negative 14. So what I'm doing is I'm adding these. 10 plus negative 12 is negative 2. 8 plus negative 15 is negative 7. 6 plus negative 20 is negative 14. 5 plus negative 24 is negative 19. I'm trying to find the one that makes negative 26. So 4 plus a negative 30 is negative 26. So there's the one that I'm after. Same thing as if I would have done this. Would have had x squared, negative 120, would have said what multiplies to be negative 120x squared and combines to be negative 26. And so then I'd put these numbers in here, 4x and negative 30x. Would have x and 4 and negative 30. So x plus 4 and x minus 30 are my factors. And that's all you have to do on that problem. You don't even have to solve it. It just says identify all of the factors. And you're done. All right, number 10, it says solve for x. Well, 30 divided by 6 is 5. So that's just really 5x squared plus 6x equals 0. So these each have an x in common, so I take it out. So 5x plus 6. And now I put each of those equal to 0, so I have x equals 0 and 5x plus 6 equals 0. So I minus the 6 minus the 6. So 5x equals negative 6 divided by 5. So x equals negative 6/5, which if I change it to a decimal is negative 1.2. The other way to do this problem is to get rid of this fraction at the beginning and multiply everything by 6. So 6 divided by 6, that goes away. So that's the first one. And 6 times 6 is 36. And then I'd still factor out an x from each of those. and then I'd have x equals 0, and 30x plus 36 equals 0. And I'd minus the 36 from each side, and divide it by 30, so x equals negative 36 over 30, which if you reduce, becomes negative 6/5, which is what we already have the answer for. So anyways, that's how you do that question, and how you would do it if it's not something that's divisible, like 30 divided by 6. You'd have to multiply by the denominator to everything, and then that cancels it off on one that has the fraction. So anyways, those are the 10 problems. Hopefully that helps you with those so that you can do the problems on the self-check. So good luck with those. And if you get stuck, let me know and I'll help you through any problem that you might have with yours.